Hello, what's going on, guys? My name is Mohammed Attab, and today we will be talking about how we could process data efficiently in a distributed environment with the help of Kafka. So let's get started. Before we dive deep into the video, here is the requirements that you need to have to follow along. You'll need Java and Spring Boot knowledge. You also need basic Kafka knowledge, so that's you need to understand what is a broker, what is a partition, and so on. You'll also need Java 11 or higher pre-installed, and finally you'll need Docker. So we'll use Docker to host our Kafka locally. So let's get started. So for this video, we will be using Conduktor, which is an amazing Kafka tool that simplifies the usage of Kafka. We will be using Docker Compose to set it up. So all we have to do, one, we need to have Docker already pre-installed. Afterward, all we have to do is just copy this link here and paste it in our CMD, and then it's going to run it's going to download the Docker Compose YAML file. Afterward, it's going to start all of the containers associated with Kafka. Let's take a look at this Docker Compose. So in here we have a console, which we could access on port 8080. And we also have many other tools that is associated with running Kafka, such as PostgreSQL, and would be also Red Panda. This is the container that has Kafka. So we could access Kafka on port. Let's see. This about this port here. So we will take a look at that soon. Alright, let's see if all the containers are up. Okay, so all the containers are up, and we could check it out in the Docker. Alright, so if you see here, Kafka is up, which is good. Right, I'm sorry, this is the port that we'll be using to access Kafka. These are the ports. All of them are associated with Kafka. So, and then once we start the containers, we could access the UI here. You have to create an account first. Afterwards, you'll get this really nice UI that helps you visualize what Kafka is doing. So before we move on to the demo, let's take a look at the theory on how we could process data in a distributed environment with the help of Kafka. So for our example here, we would be taking a look on how we could process files in a distributed environment. We need a producer, we'll need a topic, we'll also need consumers. So our producer in our example would be a Java service that has a REST endpoint that takes in files. After it takes these files, it's going to drop these files in a folder. So let's assume that's a NAS folder or a blob storage. After it drops it into that folder, it's going to produce data to our topic. Once the data is produced in our topic, our consumers would receive that data. So here's a key point that we need to keep in mind. We need at least as many partitions as there is consumers. So we'd be able to distribute the traffic among our consumers. Each consumer would be subscribed to one of these partitions inside our topic. That way Kafka is able to utilize all of our consumers, and we wouldn't have any idle service, so we could have an active architecture. We also need to produce round robin. Round robin meaning that each partition would get data. We don't want all of our data to go to one partition. This would kill this whole active architecture, and we would probably have an active passive architecture. So we want to send each record to a different partition each time. That way, these consumers, these partitions would be distributed among all of our 4 consumers. So let's take a look on how we could implement that. So I'm back here at the Conduktor UI for our Kafka. Our first step would be to create a topic. So let's go to topics, then we'd go on new topic. Our topic name would be file processing. Then I plan on having 4 consumers. What I want to do here, I want to have 2 partitions per consumer. It doesn't have to be 2 partitions, could be just 1, but my preference is 2 per consumer. So this is 8 partitions for 4 consumers, so 4 times 2 is 8. Then we would create the topic now. Alright. So now our topic is created. We could go and take a look at the Java service. So here we are at our Java service. Right, in here, let's take a look at the properties that we need to have for this project to work. First, our Bootstrap service. So this is, we need to point to our red panda inside our Docker Compose. So let's take a look. Like you see here, we have 4 ports here. It utilizes, it's essentially 4 Bootstrap servers. So we put all of them in here. So it is essentially, this is meant for redundancy purposes. So let's say one of these brokers fails, we could rely on a different broker. That way, if one fails, our project would be able to keep going and make it resilient for a distributed environment. Here we could take a look at the consumer configurations. So in here it says earliest. What that means is first come, first serve. We're going to process data in a queue, essentially. Also, the deserializer for our consumer, we're assuming that the data we're receiving is in string format, like you see up here. Here's the configuration for our producer. Same thing, we're going to produce in a string format. And down here I have some logic for our file processing. We will have a REST endpoint that takes in files. Like I said, it doesn't have to be a REST endpoint, it could be anything. So this REST endpoint will take these files, gonna drop it in the received, then it's going to submit a record to our topic, and then our consumers would be moving into either process or exception. Alright, so I created this file structure here. And after this, it assumes that this is a NAS drive that is shared by this microservice, right? This distributed microservice. So let's take a look at some of the configuration we need to have in our code. So in here, we would be creating a producer factory. So this is Kafka template. What Kafka template allows, it allows Spring Boot to manage the lifecycle. So you don't have to worry about closing the Kafka template. It will be managed for you. Similar to JDBC template. This allows us to avoid memory leaks. In here, we take a look at the Kafka listener. We would have this annotation. And here you see that I have this topic, file processing, the same topic that I created in Conduktor. And also this group ID. So this microservice would belong to this group ID here. And I have my business logic up here for processing files. I would also have controller. Is where my controller endpoint is. This is where I would be storing a file inside my NAS. Alright. All this is doing is taking whatever file I submit in the endpoint and storing it in my F drive received folder. I would be sharing all of this code in my GitHub repo, so please take a look at the description below. Alright. So let's take a look at a live demo. Alright, I'm going to run my service here. And like you see in here, these are configurations. Like you see, it says Bootstrap servers. These are the Bootstrap servers that I created, and here's my client ID. So at the bottom here, it will show, since I only have one of my microservice is running instead of all four, this one microservice will subscribe to all all 8 partitions. So whichever partition gets data is gonna get sent here. So let me start another service here. First I have to change the port number, so otherwise I wouldn't be able to start. And by the way, you would need to have allow multiple instances for this to work. So you have to go to modify options, and for operating system, allow multiple instances. Otherwise, you wouldn't be able to run the same service twice, or 3 times, 4 times, in Apache. Now, like you see here, I run this second service. Now it's only subscribed to 4. So it's sharing these partitions with this service here and that service here. So 4 partitions here and 4 partitions here. Let me start another one. And I will start the 4th one. So at the end, when I start all 4, each service would have 2 partitions that it will be sharing. Like you see here, 2 partitions, 2 partitions, 2 partitions, and so on. So let me demonstrate how I could process files in a distributed environment. Let's go. I also have Swagger UI enabled in here to simplify how we could process. Here's a dependency for Swagger UI. You also need this dependency as well for Kafka. Alright. Here's my Swagger UI. You have to go to Swagger UI /index.html. See, we have one endpoint. We're gonna click try it out, and we're gonna upload anything, new file. I'm gonna click execute. You see here, file uploaded successfully. And like you see here, one of these files is going to process that file. In our case, it's this one. This is the one that processed that file. Right. This is the one that produced the data. This is the one that processed the file. So let me run this a couple more times. And we will take a look. I'll clear everything here. I'm going to send this file multiple times to showcase how I could process this file in a distributed environment using all four. Like you see, each time it would be assigned to a different partition, and one of my services will pick it up. And here's a key point that we need to take a look at. Well, when we're configuring our producer, we need to make sure that it is round robin. If you look at our producer here, config partition class config. This needs to be round robin partition. This would allow our producer to send to a different partition each time, allowing us this, allowing each partition to receive data. So this is it. I hope you like this informative video, and I would include a link to this GitHub repo down in the description. Thank you so much. I appreciate you watching. Take care.